Hello, and welcome to my video on VLANs, or Virtual Local Area Networks. This video is a series of videos on VLANs and VLAN trunking that were done by East Carolina University students in the Cisco Academy. The configuration that follows is meant for Cisco switches, but the topologies can easily be configured for any vendor. So what are VLANs? VLAN stands for Virtual Local Area Network, or also called a virtual LAN. A VLAN is a group of logically networked devices, such as a set of computers and printers that are for a department or a building floor. You can also separate these devices on your network, such as guest devices on one VLAN and trusted users on another. A VLAN is also a logically separated subnetwork. For example, devices on VLAN 20 and VLAN 30 can't communicate between each other without a layer 3 device. So what can VLANs do? VLANs help to create a smaller broadcast domain, and therefore there is less wasted bandwidth in the domain. For example, a computer sending out a broadcast to find a DHCP server would flood the network of maybe tens of thousands of devices and therefore slow down traffic. VLANs also help to increase security, as VLANs are not visible to outside traffic. An intruder trying to connect to a computer or device on a VLAN wouldn't be easily seen from the outside if it wasn't configured to be viewable from the internet. VLANs also help to decrease costs. Building with multiple companies can use a single network infrastructure and separate the two by VLANs. It also helps to create an efficient use of bandwidth. It also helps to simplify management of devices on a network. VLANs can also be used to help route traffic. A separate VLAN can be used for voice over IP phones. It is also possible to separate wireless traffic using wireless VLANs. For example, unsecured traffic could be on a guest VLAN or an unsecure VLAN, and secure and trusted traffic could be on a staff VLAN. So now let's take a look at a network in an illustrated format and work through how we would create and configure VLAN. Here is a simple topology of a set of devices on a network. This might be how it looks in a very simple wiring closet and diagram, but can you see which nodes belong to the building floors I pictured? Or how about which devices belong into which department? From this illustration, it just looks like a group of devices connected to a switch. Here are the devices per floor. Now, it might have been easy to draw a line anywhere and guess which devices belong to which floor, but you definitely can't tell which devices belong to which department unless the suites or floors are separated by department, which might not often be the case. Here are the devices separated in departments. You can see those by the titles below each device. Looking back at the original layout, they look just like one network. Now let's single out a set of devices. For example, let's take a look at the accounting devices, which are a mix of computers, printers, and a server. So how can we connect these separated devices? VLANs are one such way. Using a VLAN would also add security. For example, sales staff would be unable to access the personal files located on the account server. Guests wouldn't be able to access the trade secrets of the research and development team. In fact, guests wouldn't even be able to know that there was a virtual and separate network for research and development. We can put all of the accounting devices on a VLAN, such as VLAN 10. Once on VLAN 10, they can no longer communicate with non-VLAN 10 devices without a level 3 switch or router. This increases their security, and it also eases their administration. Even a network that is affected, or even a network worm that affected the accounting department would be unable to affect R&D unless there's a level 3 device on the network. But VLANs don't just work locally. Combining and separating network devices in the same building, but they can also connect devices in different locations, such as connecting a sales computer in one area to a sales computer in a corporate office. To begin, we need to add a VLAN to our switching network. So how do we add a VLAN to the network? Through the command line interface on the switch, of course. If it's set up properly, you can even make it where you only need to add a VLAN to one switch, and the rest learn about the VLAN changes from that switch. In my topology, switch 0 will be the VTP 0, and all other devices are VTP clients. Now back to creating VLANs. From the configure terminal mode, we enter the command VLAN, and then a number that defines the VLAN that we want to use. Then you have a choice from the config VLAN line to add descriptors such as a VLAN label using the name command. Or you can simply type exit if that's all you want to do is create a VLAN, or once you've finished adding in your labels. In our setup, it is not necessary to enter these commands on all switches, but you may need to do so. Next, we have to configure which ports belong in which VLAN on access level switches. In the configure terminal mode, we enter the interface we wish to configure. If you have a set of ports, you can use the interface range command. For example, if ports 6 through 13 all belong to account devices, you can enter interface range fast Ethernet 0/6-13. For mine, I'm setting up that the R&D server is connected to the gigabit port switch or gigabit interface port 2. So I enter interface gigabit 1/2 and press enter. And then I type switch port mode access. This sets the switch port to an access mode, and there's only two modes, access and trunk. All devices, such as computers, printers, and servers, will be set to access mode. The next step is to set the port to a specific VLAN. And we do that by typing in the command switch port, access, VLAN, and a number. Our server needs to be on VLAN 20 with all of the R&D devices, so that's what I've typed on the screen in front of you. Once you've finished configuring the port, simply type exit, and that's all the configuration we need to configure a port to a VLAN. Now you have to do this to each switch and each port that you have a device connected to. Once configured, the last thing which you may have already done is device configuration. Devices in the same VLAN need to be on the same subnet. In my topology, research and development is a very small network, so we've given it a subnet of 254 hosts, which is part of the 10.0.1 network. And each device is configured with an IP address in that subnet. Each port that an R&D device is connected to on the switches has been set to VLAN 20. Now that that is done, all the devices are ready to communicate. In the end, the view from an administrator and device's standpoint is simplified. An R&D computer will work and act as if it is directly connected to the same switch as an R&D server. A broadcast from an R&D computer would not be seen by the entire network, but just the R&D domain. This helps to speed up processes such as finding a DHCP server or when doing a reverse query on a DNS request. And that is VLANs. I hope you've learned something about VLANs, or if you're using this video as a refresher, I hope you've now remembered all that you needed to remember about VLANs. It's important to note that one important concept of VLANs, the VLAN trunk, was not covered in this video. A later video will cover this topic.